Hey everyone, today we're looking at the higher level content with regards to our macroeconomic objective of low and stable inflation. We have two aspects to explore. First, we're going to calculate a weighted price index from a set of data, and then we're going to examine the relationship between inflation and unemployment, which is the Phillips curve. First, we will create the price index. This is essentially how CPI, the Consumer Price Index, is derived. For this course, we're going to keep it pretty simple. We'll assume this economy, Burmistan, has only three goods and services: beef, baseballs, and haircuts. The first column shows the amount of the good that is included in the basket of goods. So, for example, the average household buys 15 haircuts. Remember, the basket of goods is what an average household will buy. That's the weighting. So price indices aim to be as accurate as possible to match actual consumption habits. These weightings need to be kept constant in order to make comparisons from year to year. 2017 is going to be our base year. Every index needs a base year, so we've got a base to compare from. I want you to draw up this table in your books, so pause now and do that. Okay, you've drawn up the table. Excellent. We're going to fill it in now. First thing we need to do is calculate the value of the basket of goods and services in the base year. You've got your weights, you've got your prices, so pause now and have a go. Okay, we should have got $756. Here's how. We multiply the number of each good in the basket by the price. So for example, 37 baseballs at $3 each is $111. Then we add up these three values to get $756. All right, so I want you to pause and have a go at 2018 and 2019. Okay, here we are. So if you didn't get these values, you're just gonna have to go back and try to work out what you've done wrong, and just follow the steps that we used for working it out in 2017. Next, we are going to construct the weighted price index for the base year. So the equation is as follows, or it's down here. Price of index in year N equals the value of the basket of goods and services in year N. Okay, don't worry about that email. Divided by the value of the basket in, or that sound, divided by the value of the basket in the base year times 100. All right, so you'll see here that value of basket in 2017 over the value of the basket in the base year, which is going to be doing 756 divided by 756 times 100 equals 100. So this will always be true for the base year. The price index in the base year will always be 100. And then we can see how it's changed with reference to 100. So we're going to create the weighted price index, or weighted price indices, I should say, for 2018 and 2019. So we'll just follow the same equation, plug in the numbers. So pause and have a go. All right. So for 2018, we see 798 here divided by 756, that's the base year, times 100 equals 105.56. Unless you are told otherwise, always round to two decimal places. You can get penalized for that in exams. We've talked about this before. It's also important to remember that these price indices do not have units. So it's not $105.56. It's not 105.56 inflations. It's just 105. You may be penalized for giving an incorrect unit. So we just need to know it's nothing. All right. All right, calculating price index has no units. We need to know that. Calculating the price index for 2019, same pattern. So we do 900 divided by, again, the base year 756, 119.05. We're going to 2 decimal places again. Okay. What's next? So once we have the weighted price indices, it is relatively easy to calculate the inflation rate. It's our old friend, the percentage change. We see that a fair bit in this course. The equation is as follows: price index in year N minus price index in the previous year divided by the price index in the previous year times 100 to get the percentage. So to find the inflation rate from 2017 to 2018, we plug the numbers in. So 105.56, that was the price index for 2018, minus what it was for the previous year, divided by the previous year. So the previous year was 2017, which happened to be the base year, times 100, and we get 5.56. So we could have really done that one without the calculator. The one after the base year is always pretty basic. You can see the 105.56 directly translates over, but it's not the same for every other year. So let's look at 2019, 119.05 minus 105.56 divided by 105.56, and we should get 12.78%. Now, depending on when you do your rounding, so if you didn't round these numbers off and you just plugged them into your calculator, you would have likely got a slightly different response. You'll get equally rewarded. They do take that into consideration when they mark these papers. Okay, that's all we need to know about the price index. Right. Next, we're looking at possible relationships between unemployment and inflation. So the short run Phillips curve, that's this curve here. We show the relationship between the inflation rate and the unemployment rate. So inverse relationship, it's named after this guy, William Phillips. He's a handsome New Zealand born economist. And this relationship where there's high inflation, if there's low unemployment, will make a bit more sense. It will feel a bit more straightforward when we look at an ADAS diagram on the next slide. So here that is. Yes, here it is. So increased in aggregate demand, AD to AD1. We can see that price level increases while real GDP increases as well. As we know, the more that is produced, the more workers are needed to produce it in general. Therefore, as the inflation rate increases, price level increasing, the unemployment rate decreases. As more people working, it's going to be a lower unemployment rate. This gives the shape to the Phillips curve. So let's just go back. That gives that shape to the Phillips curve, which I'm sure you already have drawn in your notes. Correct, good. So when inflation is high, unemployment is low. When inflation is low, unemployment is high. Okay, we'll see this again. Now, the short run Phillips curve can shift outwards. This would be caused by a decrease in SRAS, the short run aggregate supply. So for example, the 1970s, there was an oil crisis. Price of oil went through the roof. There was that increased the cost of production of goods and services, and the result was higher inflation and higher unemployment. So essentially, as inflation increased from here to here, unemployment rate increased here to here, right? And that happened at every point. Now this led to what's called stagflation, persistent high inflation combined with high unemployment and stagnant demand in the economy. In the long run, the story is a little different. In the long run, the Phillips curve is vertical at the full employment level. This should look very familiar to us. This is the long run aggregate supply curve. we can show why the negative relationship between inflation and unemployment does not hold in the long run. So you've seen this before, but let's just go through it again. Let's say AD increases to AD1, causing a rise in the price level. Yes, rise in the price level and a decrease in the unemployment rate because we're producing so much. This is short term. So the Phillips curve theory holds, the short run Phillips curve holds here. In the long run, however, as employees see their buying power eroded by inflation, they'll demand higher wages. That'll increase the cost of production and shift the SRAS curve to the left. So we'll come back to that full employment equilibrium. What that means is that, therefore, in the long run, the negative relationship between inflation and unemployment does not exist. We have a higher price level and no change in unemployment, which looks just like a long-run Phillips curve. We can get higher inflation, no change in unemployment. We can go the other way as well. Okay, that's all we've got for today. Let's make sure you've got all the notes you need so we can work through this stuff. Thank you.